is Sushma, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering College. In this lecture, we are going to discuss about the methods of evaluating the convolution sum, that is linear and circular convolution. So, in this lecture, we are going to discuss briefly about the linear convolution, circular convolution, and the methods of linear convolution, that are graphical method, tabular method, and matrix method. And the methods of circular convolution, those are concentric circle method and matrix method. So in this section, we are going to discuss these methods briefly. So first of all, we will discuss what is convolution sum. So here convolution is a mathematical way of combining the two signals to form a third signal. So it is the single most important technique in digital signal processing because convolving two sequences in time domain is equivalent to the multiplying the sequences in frequency domain. So here if we take any LTI system to find out the response of LTI system y of n, if there is input of the LTI system x of n and the impulse response h of n is given, then the output response of LTI system, linear time invariant system, LTI system, that is y of n, will be calculated by the convolution sum, that is x of n convolved with the h of n. So the formula for convolution sum is y of n is equal to x of n star h of n is equal to k is equal minus infinity to plus infinity x of k into h of n minus k. This we can write as sigma k is equal minus infinity to infinity h of k and x of n minus k, because these x of n and h of n are satisfy the commutative property. So x of n convolved with the h of n is equal to the h of n is convolved with the x of n. So to find out the response of LTI system, we will go for convolution sum. So if the input of the signal x of n and the impulse response of LTI system is h of n is given, then the output response is calculated as y of n is equal x of n star h of n. So first of all, we will go discuss the linear convolution of finite sequences. This is the method, powerful analysis tool for studying the LTI systems, LTI linear time invariant system, or we can call that as linear shift invariant system. So here, what is linear convolution? Linear convolution is the basic operation to calculate the output for any linear time invariant system. If we taking LTI system, the response of that system, impulse response is given h of n and the input is given x of n, then the output response is calculated by using linear convolution, that is x of n star h of n. Here the formula for y of n is sigma k is equal minus infinity to infinity x of k into h of n minus k. So here we are taking h of n and we are doing mirror image of h of n, that is folding operation, and we are multiplying that sequence by the x of n and we are adding by using summation. So here the basic operation of convolution involves folding, shifting and multiplication and summation operations. So if we do linear convolution by any method, these are the basic steps we have to remember. So the how to find out the starting index of output sequence y of n. See here, the starting index of y of n is equal to the sum of the starting indices of x of n and h of n. Suppose I have x of n sequence is 1, 2, 3, 4 and my h of n sequence is 1, 2, 3, 4, 5 and it is starting from -2, -1, 0. The index is starting of h of n is -2, -1, 0, 1, 2. This arrow mark indicates the 0 is sample. So this is the -2 sample. So h of n is starting from the -2. X of n is starting from the 0. So to find out the starting indices of the y of n, so the starting indexes of y of n is equal to the starting indexes of the both sum of the starting indexes of the both sequences. So x of n is starting from the 0 and h of n is starting from the -2. So the y of n starting index is 0, -2, -2. Okay, and the ending index of the y of n after doing the linear convolution is equal to the sum of the ending indexes of x of n. So here this is 0, 1, 2, 3. Here the ending indexes of h of n is 2 and x of n is 3. So 3 plus 2, 5. So the starting indexes of the y of n is equal to the starting indexes of the sum of the starting indexes of the both the sequences, and the ending indexes of the y of n is the summation of ending indexes of the both the sequences. So this is the n value we have to find out. In next step, if there are L number of samples in the x of n, so if we are taking x of n, it has the L number of samples in the x of n, and in h of n, it has the m number of samples in the h of n. Then the total number of samples in the y of n, the number of samples in the output will be equal to the L plus m minus 1. So the maximum number of samples in y of n is equal to the L plus m minus 1. So this is basic steps to find out the starting index and the ending indexes of the y of n and the number of samples of y of n in linear convolution. So what are the methods to compute the convolution sum of two sequences by using linear convolution, sir? Linear convolution using graphical method, linear convolution using tabular method, linear convolution using matrix method. So here first we will discuss how to find out the linear convolution. So here in linear convolution, to find out the response of LTI system, if the system response is given, impulse response is h of n and input is x of n, then the output response will be the linear convolution of x of n star h of n. So the formula here for y of n is equal sigma k is equal minus infinity to infinity x of k into h of n minus k. For example, I want to find out this, my sequence is from -1 to 1. My y of n sequence is starting from -1 to 1. So for n is equal -1, if I substitute here for y of -1, that is -1 sample of output is equal sigma k is equal minus infinity to infinity x of k into h of -1 minus k. Okay, and if for n is equal 0, y of 0 is equal sigma k is equal minus infinity to infinity x of k into h of n is 0 here, minus k. For n is equal 1, y of 1 is equal sigma k is equal minus infinity to infinity x of k. Here h of n minus k, n is 1, so 1 minus k. So here if we observe these equations, first we have to represent these x of n and h of n sequences in terms of index x of k and h of k, and we have to fold this h of k, h of minus k we will get. Then we are doing folding operation, and either we should left shift or right shift to get the h of minus k minus 1 or h of 1 minus k. So here we are doing minus k, h of per 1 minus k, we are doing shifting operation. After getting these sequences, we are multiplying with the sequence x of k. So after that x of k into h of minus 1 minus k. Here we are doing multiplication. Then we are adding summation of k square minus infinity to infinity x of k into h of minus 1 minus k. Here we are adding those samples. So here the basic operations in the linear convolution, we are doing folding, shifting, multiplication and adding. So the basic steps for linear convolution using graphical method. Here In the graphical method, first we have to choose the starting time n for evaluating the output sequence y of n. So we have to find out what is the starting indexes of y of n. Starting index of y of n. So for that, what we have to do? We have to, for example, x of n starting index is n1 and h of n starting index is n2. Then the starting index of y of n is n1 plus n2. Here n1 plus n2. n1 is starting index of x1, n2 is starting index of h of n. The starting index of y of n will become n1 plus n2. So second step, express both the sequences x of n and h of n in terms of index k. So here we have to say whatever the sequence that we are taking, the only index is changing here, x of k and h of k. In third step, fold h of k about k is equal 0 to obtain h of minus k. And if it is to find out the h of n minus k, here if k is h of n minus k, if we want to shift it by n to the right, if n is positive, that is h of 1 minus k, 2 minus k. If n is positive, shift to the right side, shift the sequence to the right side. If n is negative, that is h of minus 1 minus k, h of minus 2 minus k, shift the sequence to the left side. And represent these sequences in the graphical method. That is nothing but sequence in the graphical representation. And multiplying the two sequences of x of k and h of n minus k element by element and sum the products to get y of n. The corresponding values of indexes we will get by multiplying the two sequences of x of k and h of n minus k by element we have to multiply and we have to add those multiplication factors here. And in step 5, after getting the values of y of n, increment the index n and shift the sequence h of n minus to the right by one sample and perform step 4. So we have to repeat this step 4 until we have to get the sum of products is 0 for all the remaining values of n. So this is a procedure for the linear convolution in the using graphical method. So what we are doing here in step 1, we are finding the starting indexes of y of n, that is n1 plus n2. n1 is the starting indexes of x of n, n2 is starting index of h of n. Then we are representing both the sequences x of n and h of n in terms of x of k and h of k. In third step, fold the h of k about k is equal 0 to obtain h of minus k and shift the whatever the sequence we are getting h of minus k. If n is positive, shift to the right side, that is h of n minus k. In h of n minus k, n is the positive, shift to the right side. If n is negative, shift that sequence to the left side. Then we will get the h of n minus k values. Then multiply with those with the x of k element by element and add the products to get y of n. And repeat this step 4 to get until the sum of the products is 0. This is the method for the graphical method, using linear convolution using the graphical method. We will see one example. Here, determine the convolution sum of two sequences using the graphical method. So here x of n is equal 4, 2, 1, 3. The sequence x of n is 4, 2, 1, 3. H of n is 1, 2, 2, 1. So this arrow mark indicates the 0th sample of your h of n. So the index starting, if the arrow mark doesn't indicate, mean the starting index of sequence is 0. So 0, 1, 2, 3. So n is equal 0. The amplitude is 4. For 1 it is 2. For 2 it is 1. For 3 it is 3. So for h of n, this arrow mark indicates the 0th sample. So this is 0th sample. This is minus 1, 1, 2. So first write down the indexes of the sequences. So here x of n starts at 0. So n1 is equal 0 here. The h of n starts at minus 1 sample. So n2 is equal minus 1. So then y of n sample starting point is, the starting index is n1 plus n2. So n1 plus n2 is 0 minus 1 minus 1. So we have to first find out the starting index of the y of n. This is the step 1. In step 2, we have to find out the total number of samples in the y of n. In the linear convolution, the total number of samples is L plus m minus 1. That is here, the number of samples in x of n is denoted by L. It is 4. And h of n, the number of samples is denoted by 4. Then the total number of samples are L plus m minus 1. That is 4 plus 4 minus 1. Total 7 samples you will get here the output. So here the starting index is minus 1 for y of n. The starting index n is equal minus 1. You have 7 samples. So it is we can calculate the ending index by using the number of samples. So that is n is equal minus 1 to 5. You have 7 samples. So in output of the y of n, you should get the 7 samples, and you have to find out the starting and ending indexes of your y of n. So this is step 2. In next step, so represent your x of n sequence. So here x of n is 4, 2, 1, 3. Represent the sequence in the graphical representation, but the index you have to represent in terms of k. So here the index we have to represent in terms of k, and h of k also we have to represent. That is h of n is here 1, 2, 2, 1, but starting index is it is minus 1. So the in graphical representation it minus 1, the amplitude is 1. Here arrow mark indicates 0 is sub. So 0 is sample, we have 2, and at 1 we have the amplitude 2, at 2 we have amplitude 1. So first we have to represent both sequences in the graphical representation with the index k. Next, here we have to fold h of k. That is, we will get the h of minus k value. H of minus k is the folding of h of k. Just mirror image of your x of k. That is nothing but it h of one sample will come to the h of minus 1 here for h of minus k, and 2 sample will come at minus 2, and minus 1 sample will come to the 1. So h of k is equal h of minus 5. Just flipping your h of k sequence, you will get this one. We have to find out the h of minus k here. So for n is equal minus 1, the formula is here y of n is equal sigma k square minus infinity to x of k h of n minus k. So for n is equal minus 1, y of minus 1 we are getting here sigma k is equal minus infinity to infinity x of k into h of here n is minus 1. So minus 1 minus k. So to get h of minus 1 minus k sample, we have to shift this h of minus 1 sample to the left side, because if h of n minus k, if n is negative value, we have to shift the sequence by h of n minus k to the left side by n units. So here h of minus 1 minus k, n is minus 1, n is negative value. We have to shift this h of k minus k sample to the left side by 1 unit. So the 1 sample of h of minus k will come to the 0 sample of h of minus 1 minus k. So only 1 unit will shift to the left side to get the h of minus 1 minus k. So it is shifting to the one side. So it is starting from minus 3, minus 2, minus 1, 0. So here to get the y of minus 1 sample value, we have to multiply this h of minus 1 minus k with the x of k sequence. So here the x of k we are representing in the graphical representation, and as well as h of minus 1 minus k also we are represented in the graphical representation. Multiply these two sequences, we will get the x of k into h of minus 1 minus k. How to multiply these two sequences? The corresponding indexes values of both sequences will be multiplied. The amplitudes will be multiplied here. So here you will get at minus 3 we don't have any sample at x of k. So 0 into 1 0, 0 into 1 0 plus at minus 2 we have to x for x of 1 it is 0, for x h of minus 1 minus k it is 2, so it is also 0 into minus 2 0. At minus 1 for x of n it is 0, so 0 into 2 you will get 0. For h of minus 1 minus k the 0th sample amplitude is 1, for x of k it is 4, so 1 into 4 plus at 1 is equal 1 of h of minus k it is 0. For x of k it is 2. So 2 into 0, 0. So finally you will get 4 into 1, 4. So the corresponding amplitudes for the corresponding indexes will be multiplied for x of k and h of minus 1 minus k, and those products will be added here. So you will get y of minus 1 value. So why we are taking here n is equal minus 1? The starting indexes of y of n will be n is equal minus 1. So from that we have to start the substitute n value. So n is equal minus 1. Next value n is equal 0. So to get the n is equal 0 value, in formula if you substitute n is equal 0, we will get the x of sigma k is equal minus infinity to infinity x of k into h of minus k. So that is the x of k will be multiplied by these two sequences will be multiplied. It's x of k into h of n minus k will be multiplied. The corresponding values will be multiplied here. So the common values we have here 0 and 1 samples. So these values will be multiplied. So 4 into 2. The 0th samples for amplitudes 4 into 2, and for 1 it is 2 into 1. So these 2 will be added. 8 plus 2, 10 you will get. For n is equal 1, if you substitute in the formula, you will get k is equal minus infinity to infinity x of k into h of 1 minus k. See here we are getting h of 1 minus k. Here, first we are representing the sequence in terms of x of k. We are folding the sequence. We are getting h of minus k. To get h of minus 1 minus k, we are doing left shift. To get h of 1 minus k, that is h of n minus k, here n is positive value. So we have to shift to the right side by 1 unit. So see here n is equal 1, whatever the h of minus k is there, this sequence will be shifted to the right side. So minus 2 sample will come to the minus 1 and minus 1 sample will come to the 0. So it is shifting to the right side by n units. N is 1 here. If it is 2, it will shift to the right side by h of minus k will be shift to the right side by 2 units. So here we have to represent every sequence in terms of graphical representation, and we have to multiply that with the x of k. The corresponding products will be added and the output will be addition of those corresponding products. So for n is equal 3, we have to represent h of 3 minus k. For n is equal 4, we have to represent h of 4 minus k. For n is equal 5, we have to represent h of 5 minus k. So every sample for that is every sequence h of 3 minus k will be multiplied by the x of k and the products will be added, then you will get the y of 3. If h of 4 minus k sequence is multiplied by the x of k and the products will be added, then you will get the y of 4. If the h of 5 minus k should multiply with the x of k and the products will be added, then you will get the y of 5. So here y of n, you will get the samples here 4, 10, 13, 13, 10, 7, 3. But here we have to represent the starting index. The 0 is sample of your y of n. So here the starting index of y of n is minus 1, 0, 1, 2, 3, 4, 5. So here we are getting 7 samples because L plus M minus 1 is equal 7. So we are totally getting 7 samples, as well as the starting index is minus 1. So the 0th sample you have to represent this arrow mark. So this arrow mark represents the 0th sample of your y of n. This is the method of linear convolution using the graphical method. So here, what are the steps we are doing in the graphical method? In step 1, find out the starting index, starting and ending indexes of y of n. Step 2, we have to find out the length of y of n. Length of y of n, that is L plus M minus 1. L is the number of samples in x of n, M is the number of samples in h of n. In step 3, represent both sequences in the index k. So represent both the sequence in terms of k. So x of k and h of k. In step 4, fold the sequence h of k, you will get the h of minus k, and find out the h of n minus k. If n is positive, shift to the right side. If n is negative, shift to the left side by n units. Okay, and multiply x of k and h of n minus k and add the products of these x of k and h of minus k, and you will get the corresponding y of n value. And repeat this loop step 5 until you have to get the sample values all sample 0. So this is the step to find out the linear convolution using graphical method. This is very basic operation to find out the response of any LTI system. So another method for linear convolution using the tabular method. This is very easy method to find out the linear convolution. Here, if the x of n sequence here, for example, I am taking x1, x2, x3, x4 and h of n in terms of h1, h2, h3, h4. The convolution of x of n and h of can be computed as per following procedure. First, we have to find out the x of n and h of n are shown in the figure. First, we have to write these sequences in any one sequence, either x or y. You can represent either column or row. So here I am taking x sample values in the representing in the row sequence x1, x2, x3, x4, the sample values of your x of n, and h of n in the column sequence h1, h2, h3, h4. Either I can represent h of in row and x in column also. Okay, and multiply the corresponding values. So x1 into h1, x2 into h1, x3 into h1, x4 into h1 and h2. Multiply each h2 into x1, h2 into x2, h2 into x3. So multiply all the values, you will get the products values. And to get the linear convolution output sequences, we have to take these columns and we have to take this is y of n. First sample is x1, h1 and second sample is addition. Whatever the products are there, we have to add in this column. So these two will be added here. So the second sample is x1, h2 plus x2, h1 and third sample is whatever the products in the third column, those will be added. So these three will be added. The fourth sample we have to add like this. This is the last sample value. This is the shortcut to find out the linear convolution using the tabular method. So multiply each and every sample in h of n with the samples of x of n and tabulate the values. Group the elements in the table by drawing diagonal lines as shown in the table. So here we have to draw the diagonal lines as shown in the table and we have to add the corresponding products in the diagonal values. we should add. This is the linear convolution using the tabular method. So here, for example, if they give the arrow mark here, so here this is the starting point, this is 0, 1, this is 1, 0 sample, 1, 2 sample. So the y of minus 1 sample will become because the starting index will be added here. Any linear convolution, the starting indexes is the sum of the starting indexes of the both the sequence. So the minus 1 plus 0. So it is minus 1. So the y of minus 1. The starting indexes of y of n will be the y of minus 1, y of 0, 1, 2. So here, first represent the sequence, any sequence in the row wise, x1, x2, x3, h1, h2 in the column wise, multiply each value with the corresponding x values and you will get the products. Then draw the diagonal lines. So the corresponding diagonal line values will be added, and for y of minus 1 it is x1 x1, y of y2 is x2 x1 plus x1 h2. This is here x1 h2, and this is these three samples. These we have to draw diagonal values like this and add the corresponding products of in the diagonal line. So for example, I am taking here it is 4, 2, 1, 3 and h of n is 1, 2, 2, 1 represented in the row wise 4, 2, 1, 3 and 1, 2, 2, 1, and corresponding values will be multiplied here. 1 into 4, 4, 1 into 2, 2, 1, 1, 3. So each h value will be multiplied by the x value. The corresponding products will be written here, and draw these diagonal values, diagonal line. Add the values in that products in the diagonal line. So first value will be 4 and second value will be 8 plus 2 and third value will be 8 plus 4 plus 1 and fourth value 4 plus 4 plus 2 plus 3 and it is 2 plus 2 plus 6 and 1 plus 6 and this is 3. So we are getting 4, 10, 13, 13, 10, 7, 3. So this is the output response of y of n where x of n and h of n is given by using linear convolution. So how to, we have to represent the index value. So here the starting index of x of n is 0 and starting index of h of n is minus 1. So n is equal to n1 plus n2 is equal minus 1. 0 minus 1 minus 1. So it is starting from minus 1, 0, 1, 2. The index is starting from minus 1, 0. So 0 sample will be indicated by arrow mark. So here the total number of samples will be L plus M minus 1. The number of samples in x of n is 4 and the number of samples in h of n is 4 minus 1, that is 7. So total 7 samples we are getting at the output. This is the method to find out the linear convolution using the tabular method. Here another method is linear convolution using the matrix method. Here if the number of elements in x of n is n1 and h of n is n2, then to find out the convolution of x of n and h of n form the following matrices. Here we have to represent the matrices. This is your output matrix, this is H matrix, this is X matrix. So how to write these matrices means the order of the matrix of H of n will be n1 plus n2 minus 1 by n2. The order of the n1 H matrix, and the order of the column matrix, that is x value is n1 by n. So the n1 is already the number of elements in x of n, so n1 by n. So here you have to multiply these two sequences, then you will get the order is n1 plus n2 minus 1. So if you see one example, it will be very easy to find out the linear convolution using the matrix method. So here we have to take h of n values, x of n values and y of n values. Here suppose x of n has the L elements and h of n has the M elements. we know the number of elements in the y of n is L plus m minus 1. So here we have to equate any one sequence to the length L plus m minus 1. Okay, so the total number of by adding the zeros, by adding zero padding, we have to make any one sequence to the length L plus n minus 1, and we have to represent here 0, 1, n2 minus 1, 0. So, and in next step, this circular rotation will come here. So, this 0 will go up and these will come down. These samples will come down. Again, this 0 will come here, 0. This 0 will come here, h of 0, h of 1, like that. These samples will come. We have to repeat this rotation up to n1. Okay, and here we have to represent x of x values in the column and multiply these two, you will get the y values. So if we see one example, it will be very easy to find the linear convolution. See here, x of n is 4, 2, 1, 3 and h of n it is 1, 2, 2, 1. Here this arrow mark indicates here 1, 2, 2, 1. So starting index 0 for x of n, it is minus for h of n. So the starting index for y of n is here n1 plus n2, that is 0, minus 1 is the starting index for the y of n. And how to represent these matrices? So H matrix. So we have here x of n 4, 2, 1, 3, 4 samples, L is equal 4, M is equal 4 samples for H of n. Okay, but any one sequence we have to make the length equal to the L plus m minus 1. So here I am taking H of n, I have 4 samples, but L plus m minus 1 we have 7. So we have to make this H of n to the equal to the L plus m minus 1 sample. So already we have 4 sample. To make the 7 sample, we have to add the 3 zeros to the H of n. Okay, so total 7 samples we are getting. Anyone, either we can take x of n or h of n. So write this in the column 1, 2, 2, 1, 0, 0, 0. So represent this first, and this will be rotated here in next column. So this 0 will come here and these samples values will come down. So 0, this 0 will come here, this 0 will come here, and next 1, 2, 2, 1, 0. Again this 0 will come here, these will come down. So 0, 1, 2, 2. Again this will go up and 0. So this matrix will be represented, the order will be n1 plus n2 minus 1 into n1. So here this will equal to the length of your x of n times we have to repeat this one and represent the x values 4 to 1 in the column. As multiply these corresponding matrices, we will get the y of n value and write down the starting indexes of the y of n represent. So 0, 1, 2, 3, 4, 5. Total L plus m minus 1, 7 samples we are getting. This is the method to find out the linear convolution using matrix method. Then circular convolution. So here in circular convolution is also known as cyclic convolution, is a special case of periodic convolution, which is the convolution of two periodic functions. So whereas in linear convolution is for aperiodic signals and circular convolution is for periodic signals. So while doing DFT, discrete Fourier, for example, if we are doing discrete Fourier transform, here we are taking the samples from 0 to n minus 1. For that we will give periodic sequences, we will use the circular convolution. So here, which is the convolution of two periodic functions that have the same period. Periodic convolution arises, for example, in the discrete Fourier transform. So the symbol for if we are taking x of n, circular convolution with the h of n, we can represent by these symbols. For linear, we are doing this star. For circular, we have to represent by this symbol. The formula for circular convolution is x3 of n. I am taking two sequences here, x1 of n and x2 of n. If we the symbol for circular convolution is this one. If we convolute these two symbols, either these satisfies the commutative property. So we can either perform x1 of n convolute with x2 of n, x2 of n is convolute with the x of n. The formula is for m is equal 0 to n minus 1. It is a periodic signal. So we are taking the finite number of samples. So 0 to n minus 1. x2 of n into x1 of n minus m modulo n. That is m is equal 0 to n, x2 of m, x1 of n minus m. This modulo n can be written as mod n also. Okay, this is the formula for circular convolution. Before going in detail about the circular convolution, we have to know what is the modulo n. What is the circular shifting? How we have to rotate the circular sequence, circular shift. So, for example, I am taking here x of n. This is the periodic signal. So, every fourth sample, same sequence is repeating. Okay, so here I am taking the only periodic samples 4, 3, 2, 1 x of n. If I want to shift this by the 2 samples to xp of n minus 2, then what will happen here? This xp of n minus 2 we can write this as the starting point, ending point of the 2 samples will go to the last. See here 4, 3, 2, 1. So these 2 samples go to the end and it will come 2, 1, 4, 3. So this is 0th sample. So 2, 1, 4, 3. The starting n naught samples will go to the ending. So here the starting here n naught is 2. So 2 samples will go to the end and this will shift to the left. So 2, 1, 4, 3. So how to represent these sequences? Take one circle and x of 0 is equal 4 and represent this in the anti-clockwise. So x of 0, x of 1, x of 2 and x of 3, represent this in the anti-clockwise, the values of x of 0. If you want to do x of n minus 2, so we have to do 2 unit circular shift. So how to do means we have to rotate in the anti-clockwise by 2 units. So these 2 samples will go to here. So the second sample will come here. So these 2 samples will go to the here and these 2 samples will. So x of the x dash of 0 will become x of 2. Because x dash of 0 is equal to x of n minus 2. That is, it will become x of 2. Okay. Next, it will become x dash of 1. So for 2 units, we have to do shifting in anti-clockwise. So here it is starting from 2, 1, 4, 3. 2, 1, 4, 3. So we have to shift in the anti-clockwise by 2 units to get the xp of n minus 2. So here the modulo n, x of n minus k mod of n is x of, we can write that as x of n minus k mod n. N is the periodicity of the number of samples in the x of n. Okay. So periodic signal x of n has 4 samples. So it will repeat after every 4 sample. It will repeat the sequence. To represent that, we will write that in mod n. So for example, if I want to shift to the xp of n minus n naught, so we delay the x of n by moving the last n naught samples of x of n to the beginning sequence. Last 2 samples will, suppose I have x of n, x naught, x1, x2, x3, x4. Last 2 samples will come to the beginning of your sequence. So x3, x4, x0, x1, x2. So after shifting 2 units, we will get this sequence. That is xn minus 2. If xn plus 2 we want to do, if n plus n naught, then move the first n samples to the end of the sequence. So here first 2 samples are x0, x1. So these will come to the end of sequence. So this will move. So x2, x3, x4. First 2 samples are x0, x1. Okay. So circular flipping generates the x of n to the x of n. So first we are taking this concentric circle. We are representing the x of 0, x anti-clockwise direction. We have to represent the sample values. and we have to rotate the that one. So here to get the x of minus 1, flipping of x of n, that is x of minus 1, just write the sequence in the clockwise direction. X of 0, x of 1, 2, 3, 4, 5, 6, 7. You will get the flipping of your x of n, that is x of minus n. So we can write x of minus n mod n as x of n minus n naught from 0 to n minus 1, because it satisfies the periodicity property. So we can write this as x of n minus n naught. So how to represent this sequence y of n is equal to 2, 3, 4, 5, 0, 0, 7. So here y of n minus 2, what we have to do here? We have to shift these two samples. See here, x of n minus n naught, moving the last n naught samples of the x of n to the beginning sequence. So last two samples are 0, 7. So these will move to the front. So it will come 0, 7, 2, 3, 4, 5, 6, 0. Last two samples minus 2. So last two samples will shift to the beginning of the sequence. If n is plus 2, the first two samples will move to the last. So first two samples remove that one. So 4, 5, 6, 0, 0, 7. And these two samples will come to the last. So y of minus n. So here y of minus n, the 0 sample will be same. And this will come 0, 7, 0, 0. Reverse order we have to write. So these are the basic circular shift operations. So if we represent that in the concentric circle method, just this is x y of 0 sample. Anti-clockwise we have to represent 2, 3, 4, 5, 2, 3, 4, 5, 6, 0, 0, 7. And move this for to n minus 2, move this to the anti-clockwise by 2 units. For n plus 2, right side. For y of n minus, just write in the clockwise. Y of n, write in the clockwise. So here the methods for circular convolutions are concentric circle method, matrix multiplication method. So here the difference between the circular and circular convolution as well as linear convolution is, in the linear convolution, if the length of the both sequence should not be equal, it may or may not be equal. But in the circular convolution, the length of the two sequences, x1 of n and x2 of n, the both sequences length should be equal. Length should be equal. We should remember this one. And the length of the y of n, the length of the y of n, if the x1 of has the L number of sample, x2 of has the m number of sample, for in circular convolution, the length of the y of n will be the maximum of L comma n. Maximum of L comma m. In linear convolution, it is L plus m minus 1. In circular convolution, it is L comma maximum of L comma n. So in concentric circle method, first we have to take the two sequences, x1 of n and x2 of n. So first we have to draw two circles like this. So in first sequence, if I have 4 samples, represent that in the anti-clockwise direction. So take two concentric circles, plot n samples of x1 of n circumference of the outer circle, maintaining equal successive points in anti-clockwise direction. So anti-clockwise direction, I am representing x1 of 0, x1 of 1, x2 of 1 and x3 of 1. This is first step. And for plotting x2 of n, the inner circle is for another sequence, x2 of n. Same sequence we have to take, same index starting, so x2 of 0. But we have to represent the sequence equal distance, write down. And we have to represent these two sequences by clockwise direction. So x2 of 1, x2 of 3 and x2 of 1, 2, 3. So outer circle in the anti-clockwise direction, inner circle in the clockwise direction. And the length of these two sequences should be equal. If this length of these two sequences is not equal also, we have to make them as equal by adding the zeros, zero padding. We have to make equal using zero padding. Okay? And multiply corresponding values. The multiply corresponding values of two circles, add them to get output. So rotate the inner circle. So first one we will get the y of 0 or y of minus 1, and next to get the next sample value, rotate the, don't change the outer circle values, only change the inner circle values by rotating one sample in the anti-clockwise direction. Rotate the inner circle by anti-clockwise direction by 1 unit at a time. So here, for example, find the circular convolution of x1 of n and x2 of n using graphical method. Here see, x1 of n, the length is 6, x2 of n length is 3. Both length L, it is m, both length are not equal. So the y of n length is maximum of L comma m, that is maximum of 6 comma 3 equal to 6. Okay. So if in circular convolution, to perform circular convolution, the both sequences should be made them equal. So in x2 of n, it has only 3 samples. We made it to the 6 samples by adding 0. So x2 of n, 3, 2, 1, we have to add 3 more zeros by 0 padding. So we have to make the length of the two sequences equal. That is 1, 2, minus 1, minus 2, 3, 1. So both the sequence length are equal by adding 0 padding. Then represent. So outer circle for x of n in the anti-clockwise direction, inner circle in the clockwise direction. Both indexes are starting x1 of 0 and x2 of 0. We should write in the anti-clockwise. So 1, 2, minus 1, minus 2, 3, 1. So anti-clockwise direction for outer circle, and for inner circle we should write in the clockwise direction. So 3, 2, 1, 0, 0. 3, 2, 1, 0, 0. So the corresponding values will be multiplied here. See, the formula for this one is y of n is equal sigma m is equal 0 to n minus 1 x1 of m, x2 of n minus m modulo n. So for y of 0, we will get sigma m is equal 0 to n minus 1, x1 of m into x2 of minus m, n is 0, modulo n. So the corresponding values will be multiplied here. And these values will be added. These products will be added to get the y of 0 value. So for y of 1, what is the formula here? Sigma m is equal 0 to n minus 1, x1 of m into x2 of, here n is 1. So 1 minus m we should get. So we should not change the outer circle because it is x1 of m only. So we should not touch the outer circle. We should rotate the inner circle by 1 unit in the anti-clockwise direction. So here we are moving. Here it is starting from 3. So it is moving here. So clockwise. So 2 will come here. 2, 3, 0, 0, 1. So we are rotating the inner circle by 1 unit in anti-clock direction, and corresponding values will be multiplied and added to get the y of minus 1. For y of 2, x2 of 2 minus n. So here 2 units will be shifted in the anti-clockwise direction of your x of minus n here. So these corresponding values will be multiplied and added to get the y of 2. So here we are maximum number we are getting the length is 6. So 6 times we have to shift the inner circle and we have to multiply the corresponding values. Here we will get the x3 of n, x2 of n, x5 of n. So 8, 9, 2, minus 6, minus 4. So here L is equal to 6, M 3. The length is maximum of L comma M, that is 6 comma 3. So the y of n length is here 6. So we are getting 6 samples at the output. This is concentric circle method or graphical method of circular convolution. So here in matrix method, whatever the sequences are there, same we have to represent like in the linear convolution only. Here, there we are making any one sample equal to the L plus M minus 1, any sequence. Here, no need to do that one. Here, whatever the sequence of x of n, x2 of n, we should make the length of these two sequences equal and write the any one sequence in the matrix form 0, 1, 2, 3, and this will repeat here 3, and this will come here 0, 1, 2, 3 will come down, and this 3 will go, and again 2 will go here 2, and 3, 0, 1 will come down, and 0 will go up, and 2, 3, 0 will up. So this is the matrix of x1. This is whatever the sequence is there, x2 of n representing the column wise x2 of 0, 1, 2, 3, and multiply those sequences, we will get the output sequence here. So to perform that one, see here, I am representing one sequence 1, 1, 2. So this will go up. So 2, 1, this will come down. So 1, 2, 1 will come here. Again 1 will go here. This will come down. 2, 1, 2. 2 will go here. These 3 will come down. 1, 2, 1. This is matrix of x1. And x2, whatever the sequence is there, write down same sequence and multiply the corresponding values. 4 plus 6 plus 2 plus 2 and multiply this with this column. 8 plus 3 plus 4 plus 1, 4 plus 6 plus 2 plus 2 and 8 plus 3 plus 4 plus 1. This is 14. 16, 14, 16. This is the values we are getting for y of n. So, what is the difference between linear and circular convolution? Here, linear convolution is a mathematical operation to calculate the output of any LTI system given its input and x of n and impulse response h of n. That will be y of n is equal x of n star h of n, that is sigma k is equal minus infinity to infinity x of k into h of n minus k. To find out the response of LTI system, to if the x of n and h of n is given, we can find that response by using linear convolution. Circular convolution is for the periodic function signals. It is for periodic signals. Linear is maybe periodic or aperiodic, but circular convolution will be the for the periodic signals only. Here, the shifting can be thought of actually being rotation. So here, it is represented by this symbol. The formula is m is equal 0 to n minus 1 x of m h of n minus m modulo n. This is formula for circular convolution. In the linear convolution, the length of the both sequence may or may not be equal, but in the circular convolution, the both sequences must be equal, and the length of the sequence will be L is equal to m plus n minus 1. We are representing here length of x plus length of y minus 1. The output number of samples will be Lx plus Ly minus 1. Here, maximum of length of two sequences we will get. So, this is the basic differences between the linear and circular convolution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.